All right, gentlemen, today we're going to talk about Chapter 7, Section 4, Parallel Lines and Proportional Parts. Anything funny to say about parallel lines and proportional parts? No? Sorry. So, when a triangle contains a line that is parallel to one of its sides, the two triangles that are formed can be proven similar by angle-angle similarity. Since the triangles are similar, the sides are proportional, or as we would say, proportionate, as it says here. That is what we call the triangle proportionality theorem. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So we have here triangle ACD, and there's segment BE, which cuts across, and it's parallel to side CD. So if BDE, segment BE, is parallel to segment CD, then AB over BC equals AE over ED. So one of the things we can look at with this, there's a couple ways to approach these problems. So let's say that we want to do this. We can find this relationship between A and B here and C and D, right? So the upper part of this triangle, I would call this part here the upper part, and this part here the upper part, okay? So we can say that upper over lower equals upper over lower. But we can also set this up to say that the tops, or the relationship of top, let's say the right-sided top over the left-sided top is equal to the right-sided bottom over the left-sided bottom. So A over C equals B over D. And either way, we're going to, if we do our cross multiplication here, if I cross multiply these things, either way, I end up with AD equals BC. So keeping all that in mind, let's start some triangle proportionality theorem example problems. Okay. So in this problem here, in triangle PQR, segment ST is parallel to segment RQ. If PT is 7.5 and TQ is 3 and SR is 2.5, find PS. Well, we're going to try this both ways. So let's label the picture. The first thing we always want to do is if we have to redraw it, redraw it. When we're taking quizzes or tests online, we'll have to redraw everything. But label it. So I've got 7.5 here, and I've got 3 here, and I've got 2.5 here, and I'm going to say this is X. So I'm going to go from top over bottom, right? So X over 2.5 equals 7.5 over 3. So now we just cross multiply. I end up with 3x equals 18.75. I'm going to divide each side by 3, and I end up with x equals 6.25. Okay. Now, let's say we decided to go a different route with this, and we wanted to work the problem from left and right, right? So as long as you match up, so I'm going to say x over 2.5. Oh, wait, we already did that one. Let's try this again. Let's say x over 7.5. Okay, I went left to right over here. Would have to equal 2.5 over 3. And when we cross multiply again, we end up with the same thing here, and we end up with the same answer down here. Now, let's try a little different problem. They change up some of the numbers here. So if PS is 12.5, so this is 12.5 here, and SR is 5, and PT is 15, then they want to find TQ, so we're going to put X there. So now we can set this up either way. Let's go this way. Let's go from bottom to top, right? So 5 over 12.5 equals x over 15. So we're going to cross multiply over here, and so 12.5x equals 75. So if I take 12.5, so 75, so 75 divided by 12.5, oops, and I get 6. Okay, and we could have done that the other way too, right? We could have done this, let's say, from right to left, right? X over 5, is that equal to 15 over 12.5? And then once you cross multiply, you still end up with the same thing here and the same answer down here. Now, we're going to talk about the converse of this, which is if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. So they're going to give you the measurements and they're going to say, hey, are these two parallel two segments? Let's take a look at this by inserting a converse of the triangle proportionality theorem example problem. So in DEF, EH is 3, HF is 9, DG is 1/3 of the length of GF. Is DE parallel to GH? Well, the one thing I know is this. We're going to label it. So, all right, so we're going to go ahead and label this now. So EH is 3 and HF is 9. Now, DG is 1/3 the length of GF. So this is a relationship of 1 to 3. It doesn't matter, 1x, 3x. We don't need to know those lengths. We just need to know we get the same cross multiplication. So here's what we know. Is DE parallel to GH? So we're going to set this up as DG, so x over 3x equals 3 over 9. Well, the quickest way to solve this or to set this up is just to cross multiply. If I get both sides equal when I cross multiply, they are parallel. So 9x equals 9x. I have cross multiplied and I have an equation here. Therefore, that is the DE is parallel to GH. Okay, so the midsegment of a triangle is the segment with endpoints which are the midpoints of two sides of a triangle, and it's called the midsegment of the triangle. So in this picture I have three midsegments. I have a midsegment right here. RP would be the midsegment for that part of the triangle. I have another one right here. And then I've got a third one right here. And what's our indicators? Well, the indicators that we have midsegments are these here for that, and each one of these. Okay, those are midpoints, right? Here's a midpoint here, here's a midpoint here. Therefore, that is a midsegment. But I have another midpoint here. So now that means this is a mid-segment, and so is this one here. So I've got three mid-segments in the drawing. Every triangle does have three mid-segments, by the way. Get that out of here. So in this case, the mid-segments of triangle ABC are segment RP, segment PQ, and segment RQ. Okay, so the triangle midsegment theorem states a midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So if J and K are midpoints of segment FH and segment HG, respectively, then segment JK is parallel to segment FG, and JK is 1/2 of FG. Let's do some example problems. So in this figure, segment XY and segment XZ are midsegments of the triangle RST. Find each measure. So XZ, well, if XZ is the midsegment and this length is 13, so this whole length here is 13. So again, this is going to be 1/2 of that. So this is going to be 6.5, right? So the segment ST, if this is 7, well, that's got to be 1/2 of the whole thing. So XE, by the way, is 6.5. We'll put that there. So ST then would be double that. So that would be 14. Okay, the measure of angle RXY. So we're trying to find here is the measurement of angle RXY. So if this is 124, then, well, that means that this segment here, this angle here is going to be congruent to this angle here and this angle here. So this is parallel to this, right? So if that's 124, this has got to be 124. And if this is 124, and those are parallel, and this is parallel, that's a parallelogram, right? So if this is 124, this is 124, this angle here has to be 56, and this is 56, which means if this is 56, then 124, 56, 56. Oh, this is 124. What am I doing? I could have just gone with the corresponding angles. What am I doing? So now I have RYX. Oh, I figured that one out. 124. Okay. Find each measure here. That's great. Segment DE. Well, segment DE is this segment right here. It's going to be half of this, so segment DE is going to be 7.5. Segment DB. Well, if segment D, if this is 9.2, and this is midpoints, right, as we say here, then we're going to double that and get 18.4. Angle FED, okay, well, if this is 82, then this angle here is 82, which means that this angle here is 82. Why? Because I have a, what inside here? I have a parallelogram. Right? Opposite sides are parallel. It's a parallelogram. So angle FED is 82 degrees. Okay, if three or more parallel lines intersect two transversals, then they cut off the transversals proportionately. So if segment AE is parallel to segment BF and segment CG, then AB over BC equals EF over FG. Some congruent parts of parallel lines. So if three or more lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So that says is we have this situation right here, that segment EF is congruent to segment FG. Some example problems. Here we go. I have two congruent segments right here. So I know right off the bat that 7x minus 2 equals 4x plus 3. So I'm going to subtract 4x from each side. I get 3x minus 2 equals 3. I'm going to add 2 to each side. 3x equals 5. Therefore, x equals 5/3 or 1 2/3, right? Over here, I have, these are parallel, right? We can see that because these first of all, because of those two little boxes there, those are corresponding angles. They are congruent. Therefore, those two lines are parallel. That means we have those. And then because of these two segments being congruent, then these two segments right here must be congruent. So I'm going to set this up as 3x minus 5 equals 2x plus 1. X minus 5 equals 1. Therefore, x equals 6.
That's all, folks.
Have fun doing the problems.